Okay, so problem 4.14. Suppose a certain series can be written like this. The sum from n equals 1 to infinity of alpha sub 0 u sub n plus alpha sub 1 u sub n plus 1 plus alpha sub 2 u sub n plus 2. Okay, where alpha sub 0 plus alpha sub 1 plus alpha sub 2 is equal to 0. Now the first question is to rewrite the general term, this general term, as an ordinary telescopic series and provide a formula for the sum. Okay, so we need to write this like in terms of two other sequences. Let's call them capital U sub n minus capital U sub n plus 1. This has to be equal to this, right? This is the idea, and now this would be a telescopic series. And now we have a hint here. He says in A, add and subtract a sub 0 times u sub n plus 1 and replace a alpha sub 2 equals minus alpha sub 0 minus alpha sub 1, right? This is what this condition entails, right? So now this is equal to, and then we're gonna subtract and sum, so this is u sub n, yes, plus alpha sub 0 u sub n plus 1, and then minus alpha sub 0 u sub n plus 1, and then we have plus alpha 1 and alpha 1 u sub n plus 1, and then we have plus alpha 2 u sub n plus 2, but this is minus alpha sub 0 u sub n plus 2 minus alpha sub 2 u sub n plus 2. Okay, so now as you can see, we have alpha sub 0 u sub n minus alpha sub 0 u sub n plus 1, alpha sub 0 u sub n plus 1, alpha 0 1 sub n u sub n plus 2, alpha 1, sorry, this is alpha 1 as well, alpha 1 u sub n plus 1 minus alpha 1 u sub n plus 2. Okay, so we could say that capital U sub n is alpha 0 u sub n plus, and then alpha 0 plus alpha 1 u sub n plus 1, right? And the general term of the sequence is the series is 1 u sub n minus u sub n plus 1. Now this series from n equals 1 to infinity of alpha 0 u n plus alpha 1 u n plus 1 plus alpha 2 u n plus 2 can be written as u sub n minus u sub n plus 1. So this series would be a telescoping series, and the result will be u1 minus the limit when n goes to infinity of u sub n. Now u sub 1 is alpha sub 0 u sub 1 plus alpha sub 0 plus alpha sub 1 u sub n, it's u sub 2. Okay, and then minus the limit when n goes to infinity of this alpha 0 u sub n plus alpha 0 plus alpha 1 u sub n plus 1. Okay, we can write it like that. Okay, so that's the result for part A. That's the formula for the sum, and now they ask us to apply this result to calculate this sum. The sum from n equals 1 to infinity of 2n plus 1 over n times n plus 1 times n plus 2, right? Now in order for this general term to look anything like this, we need to expand this in partial fractions. Okay, so let me write it like this here. This is equal to a over n plus b over n plus 1 plus c over n plus 2, where a times n plus 1 times n plus 2 plus b n plus 2 plus c n plus 1 equals 2n plus 1. Now giving values to n equals 0, these two guys go out, and you have 2 times a is 1. So now if n equals minus 1, okay, then this guy cancels out, this guy cancels out, and then we have minus 1 times 1, so this is minus b is, and then we have let me see, this is minus 2 plus 1 minus 1. okay, and if n is equal to minus 2, then we have these two guys cancel out, and then we have minus 2 plus 1 minus 2, so minus 2c, sorry, plus 2. 2c is minus 4 plus 3 minus 3. Okay, so b is 1, a is 1/2, and c is minus 3 over 2. Okay, so I can rewrite this like this, and I can write this like 2 over 2. Okay, so then I have 1/2, 1, 2 over 1/2, and then minus 1/2 over 3, so 3 over half, right? So let me erase this. So that means that we can take a common factor here, 1/2, and then we have 1n plus 2n plus 1 minus 3n plus 2, right? And so if we look at the original general series, this is u sub n here is 1 over n, right? We have alpha sub 0 is 1, alpha sub 1 is 2, alpha sub 2 is minus 3, and the condition that alpha sub 0 plus alpha sub 1 plus alpha sub 2 is 0 is fulfilled, right? Now we know that this sum is equal to this, so we have the limit, alpha 0 times, so this is 1/2 of, and then alpha 0 times u1, which is 1, so 1, and then we have plus alpha 0 plus alpha 1, 3 times u2, which is 3/2, and then minus the limit of this, that this goes to 0 and this goes to 0, so we have this, okay? This is 5 over 2 divided by 2, we have 5 over 4, okay? That's the limit of, or the value of this series, okay? That's the interesting part. Okay, now for C, they ask us to extend this argument, instead of having only 3 terms, having k terms. Okay, so we have alpha 0 un plus alpha 1 un plus 1 plus blah 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 plus alpha k un plus k. Okay, so k, it's actually k plus 1 terms. Okay, well, how can we rewrite this as a telescoping series where the alpha j from j equals 0 to k is 0? Okay, well, the strategy is the same that we have used here. Okay, and replace this. Okay, so let me write it, let me write only the general term. Okay, plus alpha k un plus k. So what I'm going to do is I'm going to write alpha 0 un plus alpha 1, sorry, I'm going to sum alpha 0 un plus 1, and then when you sum plus alpha 1, you have alpha 0 plus alpha 1 un plus 1, right? And then plus alpha k un plus k, right? And then we have minus alpha 0 un plus 1. Okay, just subtracted, add and subtracted un plus 1 times alpha 0. Now we can do the same thing with summing and subtracting alpha 0 plus alpha 1 un plus 2, so that here we have minus alpha 0 un plus 2 minus alpha 0 plus alpha 1 un plus 2, and you have here alpha 0 plus alpha 1 un plus 2, and then you have plus alpha 0 plus alpha 1 plus alpha 2 un plus 2 plus blah 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 plus alpha k un plus k, right? Okay, so now we can keep doing this, adding and subtracting, keep doing it over and over again up until we reach to the end. And let me see if I can do it here. We have alpha 0 un minus alpha 0 un plus 1, right? Plus alpha 0 plus alpha 1 un plus 1 minus alpha 0 plus alpha 1 un plus 2 plus alpha 0 plus alpha 1 plus alpha 2 un plus 2 minus alpha 0 plus alpha 1 plus alpha 2 un plus 3, right? And so you keep subtracting, you keep adding, and then here you end up with the last terms is alpha 0 plus alpha 1 plus blah 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 plus alpha n plus k minus 1 u k, sorry, it's not sorry, it's alpha k minus 1 un plus k minus 1, and then you have a last term plus alpha k, right, un plus k, yes? But alpha k is, because the sum of all terms are 0, is equal to minus, and then you have alpha 0 plus blah 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 plus alpha to n, sorry, k minus 1. Okay, so we can substitute his and say this is equal to minus alpha 0 plus alpha 1 plus blah 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 plus alpha k minus 1 u sub n plus k, right? So this is equal to this. And so now we have our general series expressed in terms of a telescopic series, right? So this is our u capital Un, and this is our capital Un plus 1. Okay, so now the series is Un minus Un plus 1. Do you see? Okay, so it's just a matter of adding and subtracting the same thing. Okay, and with this we finish the problem.